Alright, this is just a short video for two purposes. One, to review what we've been learning so far in class on Unit 2 Quadratics, and two, so that I can test automatic embedding into the WordPress site, which should speed up the process of posting videos. So remember what we've talked about so far. The key things were that quadratic equations we write in standard form this way. And to be a quadratic equation, the only requirement really is that you must have this ax squared term. A could never be equal to 0, so you got to have an x squared term in it. And then the related function to a quadratic equation is the same equation, but now instead of being equal to 0, we say y equals ax squared plus bx plus c. Again, a cannot equal 0. Okay, so this thing, when it's in a quadratic function, remember we could write that with function notation, but we said don't worry too much about that f of x quite yet. But these guys can be graphed after we had them in standard form. Okay, whereas this first one, the quadratic equation, we can solve for the particular case. In the red one here, we'd be solving for when does the equation equal 0. So we practiced writing quadratics into standard form. Here's a quick example. We might be given an original quadratic like 3x minus 4x squared plus 2y, 2y equals 7. And to put this in quadratic form, we would not leave the 4x squared, but we would leave the 2y on the left hand side. I'm going to add 4x squared to both sides, which moves it over to the right and removes it from the left. I'm going to subtract 3x from the left, which moves it over to the right. Now I've got the 7 sitting over there. That's not quite in standard quadratic function form yet. I have to divide everything by 2 to get that y alone. And so there we are in standard quadratic function form. We could see that a is 2 in this case, b negative 3 over 2, and c is 7 over 2 if we needed to do some math with those coefficients. The second thing that we learned to do is we worked on graphing quadratic functions. So let's walk through one of these problems quickly. So I'll make a simple quadratic function. Let's use y equals x squared plus, let's make it a little bit different than that because I want the math to come out nice and clean so we don't have to struggle with that part of it. Let's make this, that should be alright, x squared plus 4x minus 3. Okay, so we identify a, b, and c if we want to graph this. A is 1, the number in front of x squared. The 1 isn't shown generally, so we just have to assume, or we just know that it's 1. It's not an assumption, it is 1. B is 4 and c is negative 3, and we said the first thing you want to do is find the axis of symmetry, and the formula is just negative b over 2 times a. So negative of 4 over 2 times 1, negative 2. That's our axis of symmetry, and we can draw that in now on our graph. Step 2, now that we know the x value of the axis of symmetry, we also know the x value of the vertex. It's got to be negative 2. And what we do if we know the x value of a point is we plug that in to the function for x's, and we can find out the y value. So I'm going to do that quickly. I'm going to take negative 2 and plug it in and square it because it says x squared. Well, negative 2 squared is 4. Then 4 times negative 2 is negative 8, and then subtract 3. So we just carry out the math here. That would be a negative 4 minus 3, negative 7. So that is the x-coordinate of the vertex. -2, -7, 2, 4, 6, 7. So I'm right there. After I do that, the next thing we want to do is find the y-intercept. For the y-intercept to be on the y-axis, I know that x has to be 0, and I plug that in for x to find out the y value. And when I do that, I get the c value, -3. So there is the y-intercept. Now symmetry tells me that I also have this point on the line, on the parabola. And then lastly, we pick any other point we haven't used yet. So we have at least 2 points on each side of the vertex. I'm going to plug in the number 1. I just picked it because I wanted something that was in general to the right of that axis of symmetry. So I plug a 1 in there, and I square 1 and get 1. Add 1 times 4, so that's 5 minus 3. So when x is 1, just by plugging that x value in, I find out y is 2. Symmetry tells me these outside points are the symmetric point. And now I can draw in my parabola. So that's fairly simple. I'm going to answer just a few questions about that though. Let me erase some of this stuff. Cut all that. Questions I'll answer are like, what's the domain? Remember we said it's all real numbers. The range. Well, it starts down here at -7 and it goes up forever. Remember, range is the y values. So in interval notation, I'd say I start at -7 and I go to infinity. In set notation, it would be written this way. Y is greater than or equal to -7. Those two statements mean the same thing. I can see that it has a minimum of, what is that, -7. So that's the minimum value of the function. And that is pretty much it. So that is sections 1 and 2 basically that we've covered so far in Unit 2.